A plane hitting a building isn't just a crash, it's a chain reaction where physics, fire, and structural limits collide in seconds. Main script, doom in 13 sec. When an aircraft impacts a building, the destruction doesn't come from one event, it unfolds in stages, each amplifying the next. Let's break down the technology and physics behind it. At cruising or descent speeds, an aircraft carries enormous kinetic energy. When it strikes a structure, that energy is released almost instantly. Exterior walls, windows, and even structural elements can be torn apart on contact. At the same time, aviation fuel plays a critical role. Jet fuel can atomize into a fine mist during impact, which makes it highly flammable. When ignited, it creates a large fireball and spreads fire across multiple floors within seconds. There's also debris impact. Engines, landing gear, and structural fragments can penetrate deep into the building, damaging internal systems and increasing the affected area. After the initial impact, the situation often becomes more dangerous. Burning fuel can spread through hallways, shafts, and stairwells, allowing fire to travel vertically and horizontally. This creates multiple ignition points inside the structure. Temperatures in these fires can reach extremely high levels, hot enough to weaken common construction materials over time. Steel, for example, doesn't need to melt to fail. It loses strength significantly when exposed to sustained heat. Modern buildings are designed with safety margins, but prolonged exposure to high temperatures can reduce the load-bearing capacity of structural elements. As floors and support systems weaken, they may begin to deform or fail. If key structural components lose integrity, loads can redistribute in ways the building was not designed to handle. This can lead to progressive collapse, where failure in one section triggers additional failures below or around it. Real-world context. A well-known example is the September 11 attacks, where aircraft impacts were followed by prolonged fires that contributed to structural failure in the World Trade Center towers. Investigations showed that fire-induced weakening of structural elements played a major role in the eventual collapse. So the real danger isn't just the impact, it's the combination of high-energy collision, rapid fuel-driven fire,